Okay, so similar to our indices, there are some laws of surds that we need to remember. Luckily, there's not quite as many as with indices, there's just two in total. Make sure you copy these down. So for the first one, very, very simple. All that it is stating here is that if you have one big root sign over two things that are being multiplied together, and that's important, it works only if they're being multiplied together for this first one, then what you can do is take that one big root that you've got and you can split it into two separate ones. So what I mean by that is instead of the square root of m times n, we can now split that into two separate roots. So it's the root m times by the root n. We've split them apart. Very similar with our next one as well. We can see that this time we're not multiplying, we're doing the inverse, we're dividing, but the rule is very similar. We can see we've got one big root, which is over two things being divided, m divided by n. Now, very simply, same as before, all that we can do here is take that one big root and split it into two separate roots. So it's root m divided by root n instead. And you might be thinking at this stage, why would you ever want to do that? Why is it useful? How can we even answer higher tier questions on that? Well, you're going to be able to see that these two laws that you've got, you can apply them in lots of different ways. Let's have a look at a few of those now. So first question that we're going to look at, the first example is root 7 times by root 2. So going back to the laws of indices that we had above, it's going to be something to do with law number 1, the multiplication one. Now remember, with these laws, they actually work both ways. So yes, we could take one big root and split it into two, but we could also do the inverse. We could take our two separate and put it back as one. And that's what we're going to do here. We're going to take the two separate roots that we've got, and we're actually going to work backwards and put them under one root, like this. And then we can just simplify from there. So we can see that we've got this root of 7 times 2, which is the same as root 14, which is just written a little bit simpler than we originally had at the start. Now for the second one, we're going to do exactly the same thing again. We're going to take our two separate roots that we've got, and we're going to combine them under one bigger root. And then when we square root this, 2 times the 8 is going to give us 16. And then we actually spot at this stage, 16 is actually a nice square number. So we can square root this. The 14 wasn't nice to square root. It's going to give you an annoying decimal. So we just left it as root 14. We left it in exact form. But root 16 is nice. We know that the square root of 16 is just going to give us 4. Very similar on the next one. Again, we're multiplying. So we're going to be using that first law of surd, which is where we can take our two separate roots and we can combine them into one. But we need to be a little bit careful because we've got some coefficients here. Now remember, when you multiply, you can do it in any order. So I've got this 3 multiplied by root 11, and then we're timesing by a 6 times root 2. I can move things around though. I can actually do the 3 times 6 first to give me 18. And then I can use that first law of surds to combine the two separate roots into one. So I can take it as 11 times 2. And then simplify from there. So we're going to have 18 root 22, which simply just means 18 times by root 22, but we say it as 18 root 22. And then for the final one, we can see that we're not multiplying. This time we are dividing, but it's still the same idea. I can start by dividing the two coefficients, so the 4 divided by 2. That's nice and simple. That's going to give me a 2. And then I can take my two separate square roots and combine them into one. So I've got this 6, and I'm dividing that by a 2. And of course, 6 divided by 2, just going to give us 3. Okay, good stuff. So hopefully you've seen so far a few different ways that we can apply those laws of indices. Another way that we can apply it is by actually simplifying down one single root. So what I mean by that is on all 4 of the questions that we just looked at, we had 2 different roots. We had a root 7, root 2, a root 2, root 8, etc., etc. This next question that we've got though, we've just got a root 8. This time we're going to be using that first law of surds, but we're going to be using it the other way. We're going to be going from the green to the orange as I've drawn it on there. So what we're going to try to think of every time is a square number that goes into 8. And I'll explain on the next step why you want to do that. So a square number that goes into 8, and preferably you always want to choose the biggest square number. It's very similar to when you simplify fractions. If you can find any factor, then you can simplify down, but if you don't find the biggest factor, you might have to keep simplifying. Very similar with surds. If we can find the biggest square number, it will save us time. Biggest square number that goes into 8 is 4. And of course, 4 times by 2 gives us 8. So those two things are definitely the same. Root 8 is definitely the same as root 4 times 2, because the 4 times 2 is just 8. If you're struggling a little bit to think of these square numbers, just remember your square numbers. 1 squared, 1 times 1 is 1. 2 squared, so 2 times 2, that's going to give us 4. 3 squared, going to give us 9. 4 squared, 16. 5 squared, 25, etc., etc. Think about them like that. Going back to this question though, simplify this down, and we are going to split it into 2 separate roots. So using that first law of surds. And then the whole reason that we chose a square number was because now we can actually square root that square number. The 2 is not a square number, but the 4 is. Square root of 4 gives us 2. And we can't simplify the root 2 any further. So we leave our answer as 2 times root 2, or 2 root 2 would be even better. Exactly the same idea on the next one. We want to try and think of what the biggest square number that goes into 200 is. There's quite a few square numbers that go into that. I can think of 4 that does, I can think of 25 that does, but the biggest square number is actually 100. So first step, write a square number that is a factor of the original, and then think, right, what do I need to times that by to get the original number? But, well, obviously 100 times by 2 is going to give you that 200. Then using the first law of surds, split that into 2 separate ones. So root 100 times by root 2. And then the whole reason we chose a square number, just like before, is because now we can square root that square number. Square root of 100, going to give us 10. And then root 2, as we know, you can't simplify any further.